All right, so you've been using the standard exponential growth formula to calculate the rate of growth, the time it takes a population to growth, and the growth of a population. You also used the rule of 70 to calculate what is known as doubling time. And so doubling time on the screen is the time it takes a population to double. And so when we think about this in relation to our standard exponential growth formula, we see that a doubled population, so the final population, n, is equal to 2 times the original population. Or we can then go and look at the final population divided by the original population is going to be 2. And so the only way that works is for the population to double or multiply by a factor of 2. All right, so to show the relationship between the rule of 70 and our standard exponential growth formula, we have to start moving towards a situation where our growth rate and time are alone on one side of the equation. So in order to do that, we'll first divide by NO here, and then divide by NO there. And so those are going to cancel out, and we get this new statement that the final population divided by the original population equals the exponential function to the growth rate and t, or time. We just on the last slide stated that if it population doubles equals 2. So we can then further simplify this to 2 equals e to the rt. And so here we get a situation where we can use the natural log to further simplify our equation. All right, so what I've done is continued this derivation, and we see that if we take the natural log of both sides of our equation, we get the answer to a log is its exponent. So we take the answer from the log here, its exponent becomes the answer, and we get RT times the natural log of E equals the natural log of 2, or 0.69. And so this right here, natural log of E, has a value of 1, so we can cancel that out. And you end up, move this up. Actually, I'm going to move to the next slide. You end up with a statement R times T equals 0.69, and the 0.69 comes from the natural log of 2. In here we want to get away from our decimals, so we can multiply this by 100, and we would have to do the same thing to this side of the equation. And when we do that, we get 69 on the right hand side, and notice over here you have 100 times little r, and that's little r in a decimal. When you multiply that by 100, you just get big R, and we talked about that earlier. Big R is the growth rate in a percentage times the time equals 69. So to make our lives easier in science, we've rounded that to 70 to make some of the math a bit more straightforward. So we have RT equals 70. And then to get t alone, so remember at the beginning of this we talked about t being the amount of time it takes for a population to double. We divide by r on both sides. R cancels off, and you end up with our doubling time equaling 70 divided by big R, which is our growth rate in a percentage. So that's a quick, easy walk through how the rule of 70 is derived directly from our standard exponential growth formula.